Okay, shooting a live recording of pages 3 and 4. Having to do it in den because we're crunched on time.
Featuring Drake and Sergio.
Featuring Drake and Sergio, who don't know when to stop talking. All right, now. All right, let's zoom that in. Get this straightened out. All right, so for 22, they were asking you to solve by graphing, and so what they've done is they've given you the equation, and so this is going to be your y1, and this is going to be your y2. And so the first thing you also want to do is you want to define your origin. It's a little bit easier to see right now. You've got your x-axis here and your y-axis here. You may want to highlight that if you're trying to make it more obvious. So there's the y-axis and there is the x-axis. Okay. Now, what you basically do is you go to your calculator and you actually type in x plus 5 divided by x minus 5. Or sorry, x minus 3. And then for your secondary equation, you're going to say, okay, y is equal to 5. And you graph those two. So here you have the two parts of the rational function, and here you have the constant line y is equal to 5. So the first thing we're going to graph is that y is equal to 5. We'll do that right over there. So we go 1, 2, 3, 4, and 5. And I'm going to do that in red. Now again, you would probably use your ID card as a straight edge, but for a horizontal line that's not that hard to do. So here we have our constant line. Second thing we would need is our horizontal and our vertical asymptotes. The horizontal and vertical asymptotes. Horizontal asymptote, because these are the same, you have a horizontal asymptote of y is equal to 1, and you have a vertical asymptote where x minus 3 is equal to 0, and so that is where x is equal to 3. And so your next step is to actually draw those asymptotes so people can see it. So you have a horizontal asymptote of 1, and I'm going to do that in looking for my blue pen. Oh, we'll just do it in red. Okay. So we have a horizontal asymptote of 1, and so it's an asymptote, so I'm going to make it a dotted line at y equals 1. And then we're going to have a vertical asymptote at 3. So here's 1, 2, and 3. And then as we look at our graph on the calculator, you can see that you have a point of intersection where x is equal to 5. The two y's match up. And so you go to where x is equal to 5, 1, 2, 3, 4, 5, and where y is equal to 5, and that's your critical point. And so once you have your critical point, you can sketch the curve of the rational function. And this curve doesn't have to be too terribly perfect. The other thing you might do, just for greater degrees of specificity, is here you see the asymptote, but you also have a 0 at negative 5. And so that's important also. So you have a 0 at negative 5, so you go negative 1, negative 2, negative 3, negative 4, negative 5. And so that's right there. And so with those critical points, you can sketch a rough outline of your rational function. The important thing when you're graphing, you need to have your asymptotes, your critical points, and in this case you will also need your constant line. So your y is equal to 5 is your constant line. Okay, let's take a look at the 23. Remember, you need to label your variables. So here you have a demolition build company that wants to build a brick wall to hide the store where they hide wrecked cars. Not that interesting. One bricklayer can build it in 5 days. Another bricklayer can do it in 4 days. If the company hires both of them, how long will it take them to complete the wall? Well, the easy way to do this is you understand that it will take, that the guy who takes 5 days is slower than the guy who takes 1 day. So basically you have, in any given job situation, you have basically, you do this as 1 over 4, because it takes the first guy 4 days to do one job. And then you take 1 over 5 because it takes the other guy 5 days to do the job. And you're adding them up because they work together, and the time index would be x. Now, to solve this, what you basically wind up doing is you wind up multiplying it by the common multiple of 4 and 5. In this case, is 20. So you multiply it by 5, and you multiply it by 20 here, and you multiply it by 20 here. So now you have 20 divided by 4 is 5. 20 divided by 5 is 4. So then you have 20x. And so you add them up, and 9 is equal to 20x. And so x is equal to 20 over 9. And that's it. It's an ugly number, but it works. Now, for number 24, cyclist travels the same time as that a walker travels 3. Okay, so when you're trying to find the velocity, you remember that velocity is equal to distance divided by time. And so your velocity of the cyclist is equal to the distance, which is 3 kilometers over time. And then you also have the velocity of the walker, which is equal, the cyclist travels 8 and the walker travels 3, both in the same time. Now, the cyclist has 8 kilometers per hour more than that of the walker, which is to say that VC minus V of W is equal to 8. And so what you say is that 8 is equal to 8 over t minus 3 over t. To solve this, you would actually distribute the t. So you multiply by t here, again, to cancel the denominator. So you have 8t is equal to, now, 8 minus 3, because the t's cancel. 8t is equal to 5, and thus time is equal to 5 divided by 8, which I would leave as a fraction rather than a decimal. Now, 25 you will not need to bother with. There will be nothing like 25 on the test, and so I have chosen to omit that one. And that's going to be it for page 3. And we stop. Hopefully